Hello everyone and welcome to 1.5 complex numbers. On this one, hence the complex numbers, we're going to be talking about different types of numbers in terms of complexity. Usually in this section we're going to be talking about more about imaginary numbers, more so. Usually the three little areas that I want you guys to focus on is the arithmetic operations on complex numbers, the square roots of a negative number. So that's when you have a negative number inside a radical, like how do you get rid of it? And also complex solutions of quadratic equations. So we're going to come up with different techniques in order for us to solve for these type of complex numbers. As in the previous section, we were just dealing with just regular numbers. Now we're going to be dealing with not negative, but imaginary numbers. Usually, now for the definition of a complex number, is an expression of the form a plus bi. That form is really important. Usually on your textbooks or on the homework or on the exam, you're going to be like, solve for the complex number, and I want you to write it in standard form. And another way, standard form is just this form, a plus bi, where ab, because a, b are here, are real numbers, and I, this I part, is the imaginary part. So now we're just adding an I to the A and B, usually the real numbers here. Here are there's four I's that I want you guys to kind of, kind of memorize, but just know for future reference for when it comes to you dealing with complex numbers. When you have I, it's always equal to I. So let's say you have an I in your problem, it's always going to be I. But what if you have an I squared? You could convert that into a negative 1. Negative 1, sorry. Or vice versa. If you have a negative 1 and you want to do, and you're dealing with imaginaries, you could always put a I squared. Normally, I squared equals negative 1. If you have an I cubed, then it equals to negative I. But if you have I to the fourth, it's equal to 1. And like I said, these are usually the most important I's you should know. So if you guys want to write them down, have it on your little flashcards, if you have any, please do so, because these are important. I would recommend you guys know them. So for the following problems, I want you to express the following in the form of a plus bi. And what that just means is that I want you to kind of rewrite this in that form. So for the first problem, let's say I have 3 plus 5i plus 4 minus 2i. And I want you to solve for this. So this is just kind of going back to just regular algebra, introduction algebra, just combine like terms. So I have all the real numbers together, add them up, and then the imaginary ones together. So when you do that, you get 7 plus 3i. And that is your final answer. Remember, they want you to have it in this form, not the other one. So, well, what about this? Would this work? It wouldn't, because I want you to put it in standard form, which is a plus bi. And as you guys could tell here, a is 7 and bi is 3i. They want it in that form, not on that one, not that form. Well, what about the second one? Let's say for the second one, I have multiplication now. We have, actually no, not multiplication, subtraction. Let's say we have 3 plus 5i minus 4 minus 2i. So the first thing you should do is distribute that negative in the parentheses. Now you have 3 plus 5i minus 4 plus 2i. And again, combine like terms. So the 3 and the 4, negative 4 go together, and then the 5 and the 2 add up together. So you get in your standard form negative 1 plus 7i. Well, now, what if you have multiplication involved? Let's say you have 3 plus 5i times 4 minus 2i. So you FOIL. So same thing. It doesn't really matter what the intent is. You always go down to FOILing. So when you FOIL, you get 12 minus 6i plus 20i minus 10i squared. So keep that in mind, okay? So here you're able to combine like terms. So you get 12 plus 14i minus 10i squared. But remember, I squared, we could call that negative 1. So instead of having that I squared, replace it to negative 1. So now you have 12 plus 14i minus 10 times negative 1. Because we're just replacing that I squared to negative 1. So now you have 12 plus 14i plus 10, because you have a negative here and another negative there. So negative here, so that turns into positive. So when you combine the terms again, your final answer should be 22 plus 14i. That's your final answer. What if it's a new, completely different question? What if they're asking you to solve for I to the power of 23? You might have seen this in your classes or in your homework before. And usually these tend to be a little bit difficult, but usually they just want you to condense whatever that exponent is into something that you have seen before. So the 4 rules. In order for you to do this, what I recommend is always have them in pairs of 2. So whatever I is, just put I squared and try to condense the 23 as much as you can. So we know that if you go 12, I squared times 12, that's 24, that's over. So let's try 11. Let's try I squared to the 11. That gives us 22, right? So we're going to have that extra I. So that's fine, that's fine. So now I squared, we know that I squared is negative 1 to the power of 11 times I, right? Because we just replaced that I squared to negative 1. But now I always tell my students, is this considered an even or odd exponent? 11 is odd, so if it's something is odd, it stays as negative. If it were a positive exponent, an even exponent, then it would have been just positive. So then this turns into a negative 1 to I. So your final answer for this one is negative I. And usually these, I guarantee you're going to see them on your homework or on your exams or quizzes. So this is how you kind of condense them in order for you to try to figure out what the answer is. Now the next one is, what if you have division? And actually, I think division, I'll talk about that on its own on the next video. So right now we're going to stop here. So on the next one, we're going to be talking about dividing complex numbers, because this is a bit of a few rules that I want you guys to kind of know when it comes to dividing these. But yeah, so thank you guys for checking out the video. If you enjoyed it, please give it a like, subscribe if you haven't, and if you want to share it to your peeps, please do so. Other than that, I'll see you guys on the next video. All right, thank you guys. Bye bye.